Databases are really just a collection of data. And what most people think of when they talk about databases are database management systems, or DBMSs. That is the application that interacts with the data. This could include database management systems such as Oracle, Postgres, Redshift, or MongoDB. And there are a variety of database types, or DBMSs, including relational, object, spatial, document, or graph. But the relevant database we'll be talking about today is the relational database, or RDBMS. It's the most dominant type of database we see today. I hear people refer to it as the workhorse database, as it's the standard OLTP or transactional system used across businesses today. Standard Oracle, Postgres, MySQL are all, at their core, relational database management systems. So why call it a relation? Well, it's based on its table structure, which is called a relation, consisting of tuples, which we consider rows, and attributes, which many identify as columns. The relational database was initially designed to lend itself to declarative methods, that is, rather than specifying sequentially or algorithmically these tables, I mean relations, or querying these tables, I mean relations, it's done descriptively. So traditionally, in most parts of the world, people are taught programming languages that are imperative, where you describe step by step what is done to get the desired result. This is in contrast to declarative programming, where you describe the kind of result you want. So the most common programming language to communicate with a relational database management system is SQL, or the structured query language. This declarative language has gone through a lot of revisions, and currently we're on SQL 2011. SQL 89 and SQL 92 were very popular standards as well, and each new standard adds additional functionality to the language. For instance, SQL 92 introduced the idea of joins for linking tables together, where previously everyone was linking tables within the where clause. While it's not incorrect to utilize older standards, it's interesting to understand why some people code SQL the way they do. So let's look at the following table or relation. We'll call it the car table. It has the following attributes or columns: make, model, year, style, and horsepower, or HP for short. Now, let's say we want to ask how much horsepower or HP does the Honda 2010 Accord EXL V6 have? In standard SQL, we'd write select HP from car, where make equals Honda, and model equals Accord, and year equals 2010, and style equals EXL V6. You can see that we're describing what we want to query: horsepower from a specific type of car from the car table. This is in stark contrast to programmatically or sequentially opening up a table, reading that into a multi-dimensional array, traversing that array to find cells matching make, model, year, and style, importing that into another array, and then returning the results of that array. Not worrying about how to accomplish, but rather the what should be accomplished. SQL can be very powerful, and I've heard of our programmers importing data and writing many pages of R code that could be substantially reduced by just a few lines of SQL. Now, each DBMS may provide additional functionality, and in addition to the standard SQL. And while that can be powerful, it's better if you can stick with the standard SQL, especially if you want to readily migrate to a different database management system. Let's take a brief moment to talk about normalization. I plan on creating a separate lesson just for normalization in the future, but here we'll say that normalization is the process of taking a table and, if necessary, breaking it up in such a way as to reduce redundancy. Take a look at the following table: class. we have class, teacher, and department attributes. However, if we look closely, teacher and the department has redundant data. That is, Jones and her associated department is repeated on records 1 and 3. So to normalize this, we'll break up the table in the following way, separating the tables for teacher and department. If we want to go from class to teacher, we'll follow the TID or teacher ID, now placed on the new class table. The main benefit we can point out here is that if Ms. Jones gets married and changes her name, then we only have to update this one record in this one table. This is especially important if we were in a transactional system, but since business intelligence is not a transactional system, its necessity is argued.